What if I told you that what you see isn't always what's actually there? That your brain is constantly making guesses, filling in gaps, and sometimes even getting it completely wrong. From recognizing a familiar face to thinking you saw someone you know in a crowd. Our perception feels instant, but it's actually a complex process happening behind the scenes. Welcome to Perception and Deception. My name is Tanya, aka Tanya T, and I thank you for joining me on our podcast. Today's episode, we will be diving into how we recognize objects and faces by using the traditional view of perception. So, with further ado, let's get started. Before we get into faces and objects, let's break this down simply. Perception is how our brain takes in sensory information, like what we see, and turns it into something meaningful. So when you look at a chair, you don't just see random lines, shapes, you instantly recognize it as a chair. But here's the thing, your brain didn't just know that automatically. It had to build that understanding step by step. The traditional view of perception is based on something called bottom-up processing. This means perception starts with the smallest piece of information and builds upward. So instead of recognizing something instantly, your brain is actually detecting lines, noticing edges, identifying shapes, processing color. Then it combines all of that information to figure out what you're looking at. It's like building a puzzle. Each small piece together comes together to form the full picture. Let's talk about objects. When you recognize something like a car, your brain doesn't just say car immediately. It first processes by taking in the circles, the wheels that are circles, the windows that are rectangles, and then the overall shape. Then it compares that information to what it already knows. One traditional theory is called template matching. This suggests that your brain stores templates or mental images of objects. So when you see something, your brain tries to match it to that stored template. If it matches, then you recognize this. Now, faces are more interesting. Faces are processed in a very detailed and specialized way. Your brain looks at the space in between the eyes, the shape of the nose, and the contour of the face. And then it combines those features almost instantly. But here's where deception comes in. Have you ever thought you saw someone you knew and it wasn't them? That happens because your brain quickly matches features, but sometimes it gets it wrong. It's making a fast guess based on partial information. This is where perception becomes deceptive. Your brain is trying to be efficient, not perfect, so it fills in missing information. That's why you mistake strangers for familiar people. You see faces and objects like clouds or outlets. Optical illusions trick your brain. Your brain is constantly interpreting, not just recording reality. This happens every day. Think about walking through a crowded hallway at school. You might think you see your friend, but it turns out to be someone else. That's your brain using bottom-up processing, quickly analyzing features, but also making assumptions. It shows how powerful but imperfect our perception really is. So while perception feels automatic, it is actually a step-by-step process built from the ground up. The traditional view helps us understand how our brain takes simple visual information and turns it into meaning. But it also reminds us of something important. What we see isn't always the full truth. Sometimes it's just our brain doing its best to make sense of the world. So, without further ado, I hope you enjoyed this podcast. I hope you got to get some information. And I thank you for joining us. Hope to see you again for my third podcast, where we analyze the ecological approach. Again, thank you, and you have a good rest of your day.
Hello, everybody. Welcome to Perception and Deception with your host, Ava. This is where we're going to take hard psychology topics, break them down into simpler terms so you can better understand psychology. Some of these psychology topics are very hard to understand. They're really complicated. So we're going to take topics along the lines of perception, break them down, and you can better understand the world around you. However, there is going to be one specific approach that I talk about today and focus in on this episode. So, we are going to look at the traditional approach of perception, and we're going to kind of look at why it doesn't always work, what limitations it has, and why it's not always the most successful approach. As we know, perception is based off of how our brains see things and perceive the world around us. There is something called the loan of intelligence, which one of my podcast partners will be going over. However, I'm going to talk a little bit as to why it's a limitation of the traditional approach of perception. There are a couple reasons why. The loan of intelligence is broken down into three simple things, as we know. Perception, the way our brain perceives the world around us. Knowledge, which is something that we already know from past experiences. And experiences, things that we have done. However, there are some limitations with this. As we know, traditional approach of perception says that we already need knowledge to perceive certain things. But wait, we also gain knowledge from perception. So the big question becomes, how did perception even start in the first place? There is another limitation of this. It is known as feedback. But wait, if the brain only sees a retinal image, it has no way of knowing if the way the retinal image is seeing the world is even correct. So how do we fix that? Without feedback from the real environment that we are in as we go through these experiences, learning what around us, if it's accurate, becomes almost impossible. The third issue, which there are a lot, is evolutionary. So what really is that? Survival is something that depends on perception. So when I say this, I think of things like reproduction, getting out of danger, finding food, certain survival skills that you need. Evolution wouldn't rely on a complicated guessing system if organisms needed perception to survive. So basically, when we talk about these things, it kind of goes into play. This can be a great theory, however, there are some big limitations to it. There are also problems with something called assumption, so let's talk about it. There's three things that I want to go over with this. The first one is called local causality. The other one is called simulative assumption. And there's one more called the retinal image starting point. These are things, there's problems with assumptions themselves. This theory goes off of simple cause and effect relationships. But the real world causality is so much more complex. But it also assumes that perception is going based off of these internal copies in our brains of the world around us. But if those copies turn out to be inaccurate, our brains don't know how to take those inaccurate copies and say, oh, let me fix them. Oh, this is inaccurate. I need to shift it a little bit. Our brain doesn't know how to do that. And there's one more thing with this. When our brain takes these retinal images and only focuses on these retinal images that we have, it's ignoring things like touching, hearing, like just a bunch of different senses that we need every single day. Because of all these problems, scientists said, hey, let's try and look for an alternative approach, because clearly there are too many problems with this one. Yes, it can be successful. Yes, it can be effective. However, I'm sure there's more approaches that we can find to say, oh, maybe this one will be more successful and accurate. So, one of the most influential alternatives that they found happens to be the ecological approach. This approach basically says, instead of relying on internal guesses, this theory basically states useful information about our environment is directly available to us. That is it for my podcast episode today. I hope you enjoyed. I hope you learned a lot about perception, why the traditional approach has a bunch of limitations, and I will see you guys next episode on Perception and Deception. Thank you.
Welcome to Perception and Deception, the podcast that explores how we experience the world and why that experience isn't always accurate. Every second, your senses are taking in information, but what you actually perceive is your brain's best guess at what's out there. In this podcast, we're unpacking sensations and perceptions and looking at the different approaches psychologists use to explain them. Today, we will be looking at the traditional approach. So if you've ever wondered how you see depth, judge size, or why your brain sometimes gets tricked, you're in the right place. I'm your host, Jenna. Let's get started. Today, we are going to be talking about size perception. The traditional approach's core challenge is to perceive distance, depth, and size by rebuilding a three-dimensional world from a two-dimensional image. What I find interesting is that the retina is unclear about size. The image that is projected onto the retina not only makes it difficult to determine how far away objects are, but also how large or small they actually are. We look into something called retinal image size. This is the amount of space that an image of an object takes up on the retinal surface. While it may be a cue about depth, it actually helps us understand both distance and actual size. Let me give you an example here. Say we're in an art class and the professor brings out a puppy and drops a toy puppy right next to it and asks you to draw what you see. Easy, right? Since the two are placed right next to each other, it's very obvious you would draw the real puppy much bigger than the toy. As a result, retinal image size is a possible cue about object size. The basic rule is the larger the retinal image, the larger the object. Basically, objects that appear bigger on the retina are larger than those that appear smaller. Let's go back to that example, shall we? We're going to try something a little different this time. This time, our art professor is going to move the puppy back while leaving the toy puppy in the original spot. What we start to notice is that the actual puppy looks like it's getting smaller the further back it moves. Eventually, once it's back far enough, it will look the same size as the toy puppy right in front of you, even though we know they are two completely different sizes. Isn't it crazy how our brain can't rely on size alone to figure out how big something really is? It needs other clues about distance to figure it out. The point is, without additional information, retinal image size is completely unclear when it comes to an object's actual size. An object that produces a particular retinal image could either be small and nearby, or large and farther away. Using something called forced perspective, photographers and filmmakers do use this uncertainty to their advantage. So how would you know / figure out whether an object with a certain retinal image size is small and nearby or large and farther away? This is where cue combination becomes important. Studies show we actually do rely on several cues at once to make this judgment. Let's dive into one of those studies, shall we? In a study done by Holloway and Boring in 1941, participants looked at discs of different sizes placed at different distances. The researchers carefully paired size and distance so that regardless of how big or far away the disc was, it produced the same image size on the retina. If the retinal image size was the same each time, how were the participants able to tell them apart? The answer is they actually couldn't, at least not very well when there were few cues about the disc's distance. When the participants stayed still and looked through the peephole and used only one eye to remove depth cues, they didn't do well on the tasks. In these conditions, larger discs only looked a little bit bigger. But on the other hand, when there were more cues to distance, such as like jumping on one foot and moving around, they performed very well on the task. Basically, the more cues that were available about the distance of the discs, the more accurate perceived disc was. To conclude, the image on your retina is unclear, so it can be hard to tell both how far away something is and how big it really is. While bigger retinal image usually means bigger objects, this can be misleading because a large object far away can look the same size as a small object close up. Because of this, retinal image size alone isn't enough to judge true size. Instead, our brain uses multiple cues together, like depth and distance cues, to figure out an object's actual size. And the more cues available, the more accurate our perception is. Thanks so much for tuning in. See you next time.
Hello, my name is Sean Frederick, and I'm going to talk today about an important part of the study of sensation and perception, which is called the loan of intelligence. The loan of intelligence refers mainly to a problem created by the traditional view of sensation and perception, specifically about concepts such as the central executive, the copy of the world as perceived in our heads, and mainly the triangular view of perception, knowledge, and experience. In the traditional view of this field of study, there exists a separate entity in our heads known as the central executive, which interprets the world apart from your body and environment. The central executive creates a copy of the world in our heads separate from the actual environment, which is how we experience perception and attain knowledge. The main issue with these ideas is that the triangle of perception, knowledge, and experience has no starting point. You start with no known information about the world, and this leads to something known as the outness problem, where we cannot interact with the world around us without starting with some basic information about where that stimulation of our senses comes from. In order to learn and understand how to solve this problem, you need to take out a loan, not of money, but of intelligence. This loan is needed to figure out some things about visual perception, as you have no access to the world visually without the same senses that, among other things, gave you your retinal image on your eyes in the first place. So where does the knowledge come from that this visual representation is bad or inaccurate to real perception? Once again, you take out a loan for the knowledge that the world can be perceived, has gravity, is three-dimensional, and so on. To interpret this view of bad perception, you need cues and rules to fix it. You need to relate your view of the world to stored knowledge. Well, this brings up the question of where that knowledge comes from. Where does this information about the world around you come from? For instance, take the example of the retinal image. To solve the outness issue, you must figure out that the stimulation on the retina is coming from the world outside and not the world within. The loan of intelligence offers the information that the world is outside and some distance away from, rather than inside within you. At this point, cues and rules are needed to interpret the world. We need a lot of information to perceive the world, but the rules are needed. At this point, cues and rules are needed to interpret the world. We need a lot of information to perceive the world, but the question still remains: what is the starting point of perception? One could look to all of human evolution for that answer, seeking further and further in the past to find it. It wouldn't make sense that evolution has granted us with the ability to know stuff and do stuff directly, not without cues, without rules, or without unconscious inference. It would make more sense to have a singular approach to sensation and perception. This is a part of what's known as the ecological view. The ecological view answers this by stating that there are cues and rules of perception, which are learned because they are needed to perceive things in the first place. We learn gravity by dropping things. We learn to eat when we feel hunger, and so on. These are known as affordances. Words simply describe our perceptions as they are needed for uses out in the world. This plays a significant part in the ecological perspective by pointing out that there are flaws in the assumptions made by the traditional view. First is the assumption that all causality is local and direct. Next is that we have the assumption of representations of the world in our head, as previously stated. And finally, there's the assumption of geometric and physics variables. By removing these assumptions, the ecological view can provide some new assumptions such as non-local and non-linear causality, the organism environment as a fundamental unit of analysis, and action-relevant variables. These provide a more stable view of what is called the triangle of doom from the traditional view, and they create the bedrock to explain the nonlinear approach to perception, knowledge, and experience. These primary variables, variables that affect these parts of sensation and perception are the affordances that shape our behavior. In other words, the medium is not the message. Upon seeing an apple, what we perceive is not light or wavelengths, it is whether the apple can or cannot be grasped. This serves to better explain this starting point of how we come to sense and perceive the world. Thank you.